start again. So you remember learning about the rate of reaction? No? Yes or no? Do you know you ever learned the rate of reaction?
No.
About what, sir? About
Rate
what?
of reaction. Okay, so we start with the rate of reaction first here. So to measure rate, right? There are several ways. The first one is you can take change of mass, then you divide it by time,
Change in volume.
or it could be change in volume, and you divide it by time,
Change in density.
or it can be change in concentration, and you divide it by time. So there are a lot of methods to find the rate of reaction itself. So let's say we take an example of a reaction, carbonates, excess carbonates plus acid. What will it give us? It will give you salt, CO2, and H2O. Understand though here?
Yep.
So if you observe the experiment, and let's say you are plotting a graph of mass of carbonates, right? With respect to time, you will see the carbonates decreases, right? And here, the mass remains constant because it's in excess. So it means the acid has been used up. So if the acid has been used up, can the reaction continue?
Nope.
Anyone have questions? But if you plot a graph of a CO2, so now let's say I'm plotting a graph of volume of CO2 against time. How will the graph looks like?
Opposite to the person.
Understand?
Yes.
So you understand why at last the volume of CO2 produced remains constant already?
Yes.
Because the acid is a
You stop.
You said the volume of CO2 remains constant, right?
yeah, because the acid has been used up. And then what do you observe about the rate? Rate of reaction decreases by time, right? Can I explain why the rate of reaction decreases by time?
Because to react with
it's less concentrated.
So yeah, there are several reasons. So
less
here,
surface area.
the concentration of acid decreases, right? So the frequency of the effective collision between the carbonates and the acid also decreases, right?
Wait, are those two different reasons, or is
So it is the
one and two connected?
continuation.
Oh.
So it means the rate of reaction will decrease, right? You have any questions until here?
Wait, sorry. So, the lower the concentration, that means the less collision.
Yeah, because they were less likely to collide. That's why the concentration, that's why the rate decreases, the rate of reaction decreases. Okay?
Okay.
After the end of the meeting, I will share you a link. I'm recording the meeting.
I see that.
Why?
What?
Why? It's like, can you go back?
What is that?
Can you go back?
He record.
I record everything.
Okay.
He'll send you a link. It's
I
definitely
will
not a
upload it
virus.
to my YouTube channel. I want to be a YouTuber.
Ah, yes.
Wow.
Then at the end of the
No,
recording, he type, don't forget to like and subscribe.
I become your first
Subscribe.
subscriber, sir. I
No,
become
you don't subscribe, the score get deducted, I think.
what? Huh?
Wow.
So so can get at least 100 subscribers straight away from his whole tuition. 200.
Threaten the student and I get fired from school. Okay, if you see a questions like this, right? When will the rate of reaction will be the fastest? So the rate of reaction will be the fastest is when the time is 0. When at the start of the reaction, it will be the fastest. What is the understanding in that? So just now I sketch a graph, right? No matter which graph you are referring to, even though you take the mass of the carbonates or the time, mass of the carbonates or the volume is up to you. What can you tell me about the gradient from the graph? Decreases or increases?
Decreases.
Please.
Decreases. Okay, so gradient in maths is y over x, right? So gradient in this case is the mass over time, which means your gradient is representing what?
The rate
Therefore, the rate decreases, okay, because the gradient
decreases.
decreases. So which one is the steepest part?
The beginning.
Beginning when time equals 0.
If you draw a tangent, the steepest tangent will be at the starting of the experiment. Will there be any way steeper than this again?
Nope.
So the answer is at the t equals to 0 second. So the time is equals to 0 second, that's the fastest one, that's the greatest rate. Do you understand until here?
Yes.
Ever heard the term exo and endo, right?
Yep.
The difference between rate and yield?
Rate is the speed. Yield is the amount.
Okay, so for exothermic, the reaction need a low temperature or high temperature?
Low.
Yeah, I would say low.
It needs a lower temperature
What you mean lower gain and
or a
like
good yield.
a lower temperature to start the thing or like gain less energy, increase in the temperature?
When I say a reaction is exothermic, it means the reaction is releasing heat. So if it's releasing heat, right, if you use a high amount of temperature, you are not supporting the exothermic. Let's say I say like for example freezing. Freezing is exo-endo.
Freezing.
Melting is it?
So
Melting is endo.
no.
Melting need heat.
Oh yeah.
Freezing is it?
Exo.
Exo. So to support the exothermic reactions, mean the surrounding or the temperature that you have to give have to be a low temperature because it need to release heat. So you have to keep the temperature low to support the exothermic reaction.
Wait, sir. So you're talking about the surrounding temperature?
No. I'm talking about not the surrounding temperature. The temperature that you have to give to the system have to be a lower temperature. You have to give a low temperature to the system so that the exothermic reaction can proceed.
So like temperature like 10 degrees Celsius is given.
I'm not discussing it. Temperature. It depends on the type of. It depends on what chemical reaction takes place.
So lower in comparison to endothermic.
Yeah, but what I want to highlight here is for exothermic reaction, when you give the temperature, when you set the temperature low, you get a good yield, but then not a good rate.
Isn't that better?
You have a result. You got a good result, but then the time will be very long. You understand my statement or not?
Yes.
Yes.
Okay. For endothermic,
High temperature for good yield.
it needs a higher temperature for good yield, and
Good rate, is it?
if a high temperature is given, the rate also will be
Better. Gooder.
Good.
More good.
And the rate.
and the rate also will increase at a higher temperature.
Sir, what if I for
Conclusion is what?
exothermic? What if I
What is
want
the
the
conclusion? It means for both endo and exo, high temperature will give a faster
Rate.
rate. What's your question, giving?
so if I just want a good faster rate but a worse yield, then just switch it for exothermic. I mean,
Yeah.
just increase the temperature.
Yeah, if you
Endothermic.
want to have a good rate, right? If you want to have a good rate, the temperature have to be high. But then no, it's not the discussion for the yield. The discussion for the yield is another story again.
Okay.
Others have questions?
Fun time.
Okay, now we are going to discuss about equilibrium. Have you heard the term equilibrium?
Equal.
Total net force equals 0. Something equal.
You see the arrow? What does the arrow means?
It can switch back and forth.
Yeah.
It is indecisive.
So the discussion of equilibrium. To discuss equilibrium, you need a closed container. If there's not a closed container, if you let it be exposed to the surrounding, there's no discussion about equilibrium. Okay, so actually, what is the meaning of equilibrium itself? When I say equilibrium, right, it means you have reached a moment where the concentration of a product and reactant remains constant. So they no longer react, they no longer move forward or backward. The concentration have stayed constant. And the second one is the rate of forward reaction is equal to the rate of backward reaction. You have to listen more for this number 2. So now let's say you start the experiment by adding A and B. So when you add A and B, they will react to produce
C and D.
C and D. When the C and D getting more and more, the A and B finish, right? Or slowly use up, right? Because the C and D is getting more and more, the C and D also will react to produce what back again?
A and B.
To produce A and B. So when will this reaction stop? When the reaction stop, it means they have reached equilibrium. So when it says that it reaches equilibrium, it means the rate of the forward reaction and the rate of backward reaction is
Same.
equal already. So at the first time, right, when you react this thing, right, it's not constant. So it means they will go forward first, then they will find their own balance point. But then to have this discussion, right, you have to make sure it's a closed container. If it's not closed container, that means you will lose some of the reactants or the products. It will escape air, and they cannot reach equilibrium. Do you have any questions until here?
Wait, so after it reaches equilibrium, then it just stops the reaction.
Yeah.
Then when we take it out from the container, will
Take
it?
it out or not, that's another discussion. But then, I mean, it sounds like equilibrium. That's the meaning of equilibrium.
Okay.
I want you to think first. Right? Think. If the concentration of A
Think.
is increased, where will the equilibrium go?
Wait, what?
It will go over the rainbows.
Left or right?
Wait.
When you increase the amount of A, that means you have more A, right?
Hmm.
Yeah.
Just now I say to reach equilibrium,
Right.
the rate have to be equals and the concentration have to remain constant. It's simple. When you add A, when you add A, it means automatically A and B will react, right?
Hmm.
If A and B react, where will your reaction go?
And D,
If A and B react, it will produce
C and D.
C and
D.
D.
Okay.
You understand though there?
Yes.
So if it produces C and D, if it produces C and D, it means your reaction proceed where? Forward or backward?
Forward.
Or
So your reaction produce proceed where? Forward, right?
Yeah.
So means the answer, the equilibrium will move forward.
Okay, D, what is this?
what does that mean, sir?
When you add the concentration of A, the A and B right, will react. They will collide and they will react right, with one another. After they react with one another, they will produce more product, right?
Yes.
They produce more product. So when they produce more product, we say the reaction proceed
Forward.
Or
forward, not backward. If the reaction proceed backward, means what do you produce?
A and B.
If the reaction proceed backward, means you produce A and B. But then when you add A and B, you get a C and D. So the reaction not proceed backward, but the reaction proceed forward. The reaction proceed forward. That's why I say the equilibrium shift to the right or move forward. Any question?
do you mean like position in the container?
Yes. So now if the concentration of C is decreased,
Wait, sir, are like the A and B on like opposite sides of the container?
no opposite side. They are the reactants. They are in one container also. There are particle A, B, C, and D. Okay, now go to number 2 first. If you reduce the concentration of C, can you expect C and D to react to give you more A and B?
No.
No.
So because you decrease the concentration of C and D at here, because you reduce the concentration of C, then I cannot expect C to react with D. So what will react?
A and B.
A and
A
B.
and B will react to give you what?
C and D.
To give you C and D. So you say A and B will react to give you C and D. So means your equilibrium shift right?
Forward.
The equilibrium still shift forward.
How can equilibrium?
For those who doesn't understand this concept, you just think of you are dealing with a simple balancer. So you have A and B on one side. You have C and D on the other side. Our concern is to make the balance stay constant. So when your friend add the amount of A, what happened to this balance? It will move where? It will fall to which side?
Where?
Fall to left side, right? So where should you add extra load? Right side or left side to balance it back?
Right side.
But
Right side. That's why we say the reaction shift forward.
Okay, so that is what. Okay.
So if I decrease the concentration of C, if this is decreased, where will the balance go? It fall to which side?
A.
Also fall to the left side, right?
Yeah.
So where should you add the extra load? to help these things balance back.
C and D.
Also at the right side, right?
Yeah.
So also shift.
To the right.
Also shift what?
Forward.
Forward. Right? Question, please.
No.
Clear?
Uh,
Clear or not?
wait.
The number 2, I not really understand also.
Number 2, when you decrease the concentration of C, right, this balance, this plank, will fall to where? Will tip to where?
A and B.
Left side, right? How are we going to balance it back? Where should we put the extra load?
Put at A and B. No.
The balance fall to the left side already. So where should you add the load again to balance it back? You add it to A.
C and D.
Okay, that's why you say the equilibrium shift forward.
Okay.
Understand till here?
So doesn't that mean that in the end, there's more A and B than C and D?
You're gonna have to think more, because in equilibrium, right? You have to make sure when you say that it reaches equilibrium, the concentration of the product and the reactants remains constant already. So
But you
if
say
one
there's-
side is more, right? If one side is more, they will find a balance point. They will react with one another, and then it will be balanced at last. So they have to fulfill the 2 points that I tell you earlier.
Oh, so you're saying A, B, C, D are all in the container. Then A and B react to form C. Oh, okay.
So you have 4 things, right? A, B, C, D. So A and B collide to form C and D. Later, when you have too many C and D already, right? The C and D will collide to form what?
And
A and B.
A and B. So until when will this thing stop? Until they reach that 2 points that are right in the blue color, and when the concentration of product and the reactants remains constant, so they will react until the concentration remains constant, and the rate of forward have to be equal to the rate of backward reaction. Any question you'd like to ask?
No.
No. I still owe you one MCQ paper. Okay, I'll discuss that on the next meeting.
It's okay. So you don't need to owe us one.
If no questions, I will clear the board.
and bye. Yeah.
And the next meeting, I will continue again explaining about this one, the rate and the stuff. Okay.
Enjoy the rest of the time.
Remember to revise. And see you tomorrow for A
Sir,
maths.
when are
Right?
you gonna send the link?
What?
When are you gonna send the link?
As soon as possible. Remember to subscribe. Yeah. No, just
Is it a YouTube link?
send
What
the
kind of
link
link?
as soon as possible when I got it from the cloud. Okay?
Yeah.
Bye. The meeting ready.
Bye.
Thing.
Bye, sir.
YouTube, so don't worry, we'll subscribe.
Yes, sir. What's your YouTube, sir?
Bye.